Alright, this is page 3 now. We know that AB is an altitude of triangle IAK. An altitude starts at a vertex and is perpendicular to the opposite side, which means if two lines are perpendicular, they have to intersect at a right angle. So we know that AJI is a right angle, and we also know that AJK is also a right angle. So out of these four options, if any of them exist, we want to see which of the information here is true based on this picture. So the first letter A says that AJ is congruent to BJ. If J was the midpoint of AB, then this would be true, but we don't know that J is the midpoint of that, so option A doesn't work. Angle IAJ, this angle right here, is a right angle. We know that's not true, because the only right angles in this triangle are IJA and AJK. C says IJ is congruent to JK. That would be true if J was the midpoint of IK, but since the altitude doesn't have to go through the midpoint, we know that that doesn't have to be true. And then D, A is the midpoint of I and K. Well, in order to be a midpoint of IK, they would have to be on the same line, and I, A, and K are not on the same line, so that is also not true. So none of those statements can you conclude is true from the given information. Okay, B, 13B. We're going to name an angle bisector. One angle bisector cuts an angle into two equal parts. So if you look at the picture, are there any two angles that are congruent on either side of a segment or array? And right here, you have this angle here is congruent to this angle here. So that means that line segment CE, okay, has to be your angle bisector. Name an altitude. So just over here we said it has to start from a vertex and it has to be perpendicular to the opposite side, which means it has to form a right angle. Here's a vertex where a line starts, it drops down, is perpendicular to the opposite side, so that makes segment AF an altitude. A median goes from a vertex to the midpoint of the opposite side. If you look at segment AC, this segment AD and segment DC are congruent, which makes D the midpoint. And from D, from the midpoint of the opposite side, you have a segment that starts at a vertex B and goes to that midpoint, so that makes BD the median of that triangle. Okay, if D is the midpoint of AC, which it is, then BD is what kind of a segment? Well, we kind of just did that here. That makes BD a median. Okay, because D is the midpoint of AC, and B starts at a vertex. Alright, find the value of the variables A and B. Alright, well, just by looking at these triangles, I know there's a 90-degree angle here. I know this part of the angle is 40, which makes this angle right here 50, because added together gives you the 90. I also know that this triangle is 180 degrees, since all three angles add to 180 in a triangle. So if I take away 50 degrees from 180 and also take away 66, I'm left with 64 degrees for angle B. I also know that angle 66, the measure of this angle right here and the measure of this angle right here, form a linear pair. That means their sum is 180 degrees, so 180 minus 66 tells me that this angle is 114. Then I have another triangle where the sum of the angles has to be 180. So I'm going to take 180, subtract 40, which gives you 140. And then I'm going to subtract the 114 from the 140, and I'm left with angle A, which is 26 degrees. Okay, the last problem on that page, 15. I'm going to use the triangles below to explain how I can prove that FG, that this side right here, is congruent to DG. The first thing I'm going to do is separate the two triangles so I can get a better picture of what I'm looking at. So anytime you have a situation where triangles are overlapping, it's best to separate the two, redraw them, and then fill in the information that they give you so that you can see more clearly what is actually going on. H, G, and D. Okay, so I know these are the two triangles I'm looking at, and from the original picture I knew that angle F is congruent to D. So that's one part I already know. I was also given that HD, this side right here, is congruent to JF, so there's two things I know. And the third thing I know in both triangles is that angle G is congruent to angle G by the reflexive property. And what the reflexive property means is that since they both have angle G, this angle in both triangles, that angle G is congruent to itself. So angle G is congruent to angle G. That's what makes that reflexive property. So now I have three things in this triangle, and I have three things in this triangle. I now know that triangle FJG is congruent to triangle DHG by, I have two angles and a side, and the side is not in between the two angles, so they're congruent by angle, angle, side, angle, angle, side, angle, angle, side. Okay, so now I know that this triangle and this triangle, everything is congruent. So how do I prove that FG, that this side right here, is now congruent to this triangle? Well, since both triangles are now congruent, I know that the corresponding sides are also congruent. So I know FG is congruent to DG by what we learned was CPCTC, which says corresponding parts, so corresponding sides in this case, of congruent triangles, of these two triangles, are congruent. So now we know that anything else from this triangle has to be congruent to this triangle because the corresponding parts are now congruent.